Hello students, today I am going to discuss the topic incidence matrix representation of an undirected graph. So we have already discussed that the adjacency matrix representation of both directed as well as undirected graphs. Okay, so here we have to consider an undirected graph. Coming to the definition, consider an undirected graph which has n vertices and m edges, all should be labeled. Okay, so then the incident matrix I of g should be an n by m matrix. It means we have to consider the vertices as rows and edges as columns in the respective incident matrix. Okay, now we have to construct the matrix over rows, over vertices and edges. Whereas in adjacency matrix, we have constructed the matrix over vertices only. Okay, but here we have to construct the matrix over vertices and edges. Okay, so for understanding, I am giving you one example that find the incidence matrix to represent the graph. To represent the graph. And here the graph is, so we are having four vertices in the given graph. So those are V1, V2, V3 and V4. And coming to the edges, from V1 to V2 we are having an edge. From V2 to V3 also we are having an edge. From V3 to V4 also we are having an edge. And from V4 to V1 also we are having an edge. And also we are having from V1 to V3 also an edge. And all these are labeled. It means this one, this is E1, this is E2, this is E3, this is E4 and this is E5. So this was the given graph. Of course, this is an undirected graph. Okay. Now we have to find the corresponding incident matrix for the given undirected graph. Okay. So coming to the solution, from the given graph, we observe that there are four vertices V1, V2, V3, V4 and 5 labeled edges E1, E2, E3, E4, E5. Okay, so we are having four vertices and 5 edges. Therefore, the incidence matrix is of order 4 by 5. So the corresponding incident matrix should be of order 4 by 5. So whenever we are having four vertices and 5 edges, so the incident matrix should be of order 4 by 5. Okay, so now we are going to construct the incident matrix. Okay, right. So we have to represent the vertices along rows. So that I am writing V1, V2, V3 and V4 and edges along columns. So E1, E2, E3, E4 and E5. Okay, so now coming to the matrix, the first entry should be V1 E1. It means is the edge even incident on the vertex V1 or not from the given graph. Yes, clearly we observe that the edge E1 should be incident on V1. So that we have to write 1. Okay. So coming to next element, that is V1 E2. Is the edge E2 incident on V1 or not? No. E2 is not incident on the vertex V1. So that we have to write 0. Similarly, is the edge E3 incident on the vertex V1 or not? No, that is not incident on the vertex V1. So that once again you have to write 0. Coming to the E4, is the edge E4 incident on the vertex V1 or not? Yes, E4 is incident on the vertex V1. So that we have to write 1. Coming to the E5, clearly E5 is incident on the vertex V1. So that we have to write 1. So this is first row. So coming to the second row, so now V2 E1, it means is the edge E1 incident on V2 or not? Yes, it is incident. Since the given graph is an undirected graph, so that E1 is incident on both the vertices V1 and V2. So that we have to write here 1. So coming to the E2, V2 E2, is the edge E2 incident on the vertex V2 or not? Yes, it is incident. So that we have to write once again. So coming to E3, E3 is not incident on the vertex V2, so that we have to write 0. And E4 also not incident on V2, so that we have to write 0. E5 also not incident on V2, so that we have to write 0 once again. Okay, second row completed. So coming to the third row, so V3 E1, is the edge E1 incident on the vertex V3 or not? No, so we have to write 0. V3 E2, yes, E2 is incident on both the vertices V2 as well as V3, so that we have to write 1. So the edge V3 is incident on V3, so that we have to write 1. The edge E4 is not incident on V3, so that we have to write 0. And the edge E5 is incident on V3, so that we have to write 1. Okay. So coming to the next row, that is fourth row. So this is V4. So V4 E1, is the edge E1 incident on the vertex V4? No, that is not incident on V4. So that we have to write 0. So coming to the E2, E2 is also not incident on the vertex V4. So that once again you have to write 0. Coming to the E3, E3 is incident on V4. So that we have to write 1. E4 also incident on V4. So that we have to write 1. Coming to E5, E5 is not incident on the vertex V4. So that we have to write 0. Okay, so this is the corresponding incident matrix of order 4 by 5. In this way, we can construct the incident matrix corresponding to the given undirected graph. Okay, so coming to the next example. So coming to the second problem, so find the incident matrix corresponding to the graph. Of course, once again, this is an undirected graph. So now we have to find the incident matrix for this undirected graph. So once again, if you observe the given graph, there are 4 vertices and 5 edges which are labeled. Once again, we get 4 by 5 incident matrix. Okay. So once again, I am writing the solution. Since the given graph contains 4 vertices. Here the vertices are A comma B comma C comma D, and 5 edges E1 comma E2 comma E3 comma E4 comma E5, which are labeled. Therefore, the incidence matrix the incidence matrix is of order. So since we are having 4 vertices, so first we have to write 4, and we are having 5 edges, so that we get incident matrix of order 4 by 5. Okay, so in adjacency matrix we have to represent the matrix over vertices only. Okay, in both rows and columns we have to consider only the vertices, whereas in incident matrix we have to consider the matrix over vertices and edges. Okay, so the required incident matrix should be of order 4 by 5. So once again I am representing the vertices A, B, C and D along the rows, and the edges E1, E2, E3, E4 and E5 along columns. So once again we have to find the matrix, right? So coming to the first element, that is A1. Is the edge E1 incident on the vertex A? Yes. So E1 is incident on both the vertices A and B, so that we have to write one here and also one here. Okay. So coming to the next second element, is the edge E2 incident on the vertex A or not? Yes, it is incident, so that we have to write one. And A is also and E2 is also incident on D. Okay, so that we have to write in place of D corresponding to E2 also 1. Okay, so coming to the third element, is the edge E3 incident on the vertex A or not? Yes, it is incident, so that we have to write 1. And E4 is not incident on A, so that we have to write 0. And also E5 is not incident on the vertex A, so that we have to write 0. Coming to the second row, yes, E1 is incident on B, so that we have to write 1. And E2 is not incident on B, so that we have to write 0. E3 is also not incident on B, so that we have to write 0. And E4 is incident on B, so that we have to write 1. And E5 is not incident on B, so that we have to write 0. So coming to the third row, so E1 is not incident on C, so that we have to write 0. E2 is not incident on C, once again you have to write 0. E3 is incident on C, so that we have to write 1. E4 is not incident on C, so that we have to write 0. And E5 is also incident on C, so that we have to write 1. And coming to the last row, so E1 is not incident on D, so that we have to write 0. B is incident on D, so that we have to write 1. Okay, so coming to the E3, E3 is not incident on D, so that we have to write 0. E4 is incident on D, so that we have to write 1. And E5 is also incident on D, so that we have to write 1. So this is the corresponding incident matrix of order 4 by 5. So in this way, we can represent the matrix corresponding to the given undirected graph. Okay. We can also represent an undirected graph corresponding to the given incident matrix. Okay, so I am doing one problem that we have to represent the undirected graph corresponding to the given incident matrix. So that write down the problem. Draw the graph of the given incidence matrix. Of the given incident matrix, and the matrix is 0 1 0 0 1 0 1 1 1 0 1 0 0 1 0 and 1 0 1 0 1. So this is the given incident matrix. Now we have to represent the graph corresponding to the given incident matrix. Okay, Since the given matrix is of order 4 by 5, so that by seeing the order, we say that so in the given in the graph there are 4 vertices and 5 edges. Okay, by seeing the order of the matrix, we say that so there are 4 vertices in the graph and also 5 edges in the graph. Okay, so coming to the solution, since the given matrix contains 4 rows and 5 columns, so we have 4 vertices and 4 vertices denoted by I am denoting the vertices by A comma B comma C comma D. Okay, A comma B comma C comma D. And since we are having 5 columns, so that we say that there are 5 edges. 5 edges denoted by E1 comma E2 comma E3 comma E4 and E5. Okay, E4 and E5, right? So therefore the undirected graph of the given incidence matrix is, so since we are having 4 vertices, so that I am representing the vertices as A, B, C and D. Okay, these are the vertices. So this is A, this is B, this is C and this is T. Okay, so coming to the matrix, yes, so we have to write down the names of the vertices as A, B, C and D along rows, and also names of the edges along columns E1, E2, E3, E4 and E5, right? So by seeing the matrix, now we have to draw the edges. Okay, so from A to E1 we are not having an edge since we are having 0. Okay, so E1 is not incident on A, so that we cannot draw an edge from A. Okay, right. Next, E2 is incident on A. It means we have to draw an edge from E2. Sorry, it means we have to draw an edge from A. So and that E2 is also incident on B, so that we have to draw an edge from A to B and name it as E2. Okay, E2 is incident on both the vertices A and B. So coming to the edge E3, E3 is not incident on A, so that we cannot draw an edge. E4 also not incident on A. E5 is incident on A. E5 is also incident on D. Okay, so if you observe ones, so we are having ones at A and also at D. So corresponding to E5, it means E5 is edge incident on both the vertices A and D, so that we have to draw an edge from A to D and named it as E5. Okay, first row is completed. So coming to the second row, so E2 is incident on B. Yes, we have already represented that. So E3 is also incident on B and also E3 is incident on D. Okay, it means in between BD we are having an edge, and that should be named as E3. This is E3. Okay, so E4 is also incident on B and also on C, so that we have to draw an edge from B to C and name it as E4. Okay, so second row is also completed. So coming to the third row, so we are having an edge E1 incident on both C and also on D. So in between CD, we are having an edge that is even, so that we have to write even. And after that, we are having an edge E4 incident on C as well as on B. Yes, we are already represented the edge E4. Okay. So coming to the last row, so E1 is incident on the vertex D. Yes, that was already represented. Coming to the E3, E3 is incident on both B and D. Yes, that was already represented. And E5 is incident on both A and D. That was also represented. Okay, so this is the corresponding undirected graph to the given incident matrix. So in this way, we can represent the graph corresponding to the given incident matrix and also the incident matrix corresponding to the given undirected graphs. Okay, thank you.